All right, here we go. Moving on into section 5.6, the remainder and factor theorems. And what these are going to do is set us up for how we're going to solve polynomial equations in the last two sections of chapter 5. All right, so we're going to go back and we're going to think about some stuff that we used early on in the chapter. So when we divide polynomials, remember our divisor is x minus r. And then when we would divide, we'd either use this whole thing in long division, or we'd take the opposite of the minus r, so just what r was, and plug that in for synthetic division. So if you want to find the value for a function at any given number, say, what is 3? When x is 3, what does the function equal? You plug 3 into the equation and simplify. You've been doing that for years. Well, guess what? There's another way we can do that. And you're going to look at this and go, well, why would I want to do this? Plugging in is just as fast. Yes, and I'll get to a reason why you might want to do this at some point. Another method to get the solution is to make the number plugged in for r and divide the polynomial. And so we're going to, in this case, like the 3 would become r, and then we divide. The resulting remainder is the solution. And this is called the remainder theorem. So I'm going to show you how it works with a simple problem, and then we'll look at why do we want to use this with slightly more complex problems. So first of all, let's just do this the good old-fashioned way. When x is 3, so it's saying f of 3. So when x is 3, what does the equation equal? What's the function equal? So we would take and we'd plug it in. Negative 3 times 3 squared plus 5 times 3 plus 4. Now you have to remember order of operations. Remember that we square first, then multiply by negative 3. Every once in a while, people have a tendency to multiply, then square. Don't do that. Okay, so if we do that, if we do this the correct way, we'd have negative 3 times 9 plus 15 plus 4. Negative 3 times 9 is negative 27 plus 15 plus 4 equals negative 8. Okay, that's not bad. It's a squared polynomial, not that bad. Now let's just quickly review the long division and the synthetic division. So if we did this with long division, here's our 3, here's r. That's our divisor, and we're going to see how many times does it go into negative 3x squared plus 5x plus 4. And remember, when we do our long division, we focus, for the divide step, we look at the dividend, the first term of the dividend, and the first term of the divisor. So what's negative 3x squared divided by x? That simplifies to negative 3x. So we write that over the x term. Then we multiply. Negative 3x times x is negative 3x squared. Negative 3x plus 3 is plus 9x. Now remember, we have to subtract the whole thing. So when we subtract negative 3 minus negative 3x, that makes that 0. 5x minus 9x is minus 4x. Bring down your 4. Now we're going to focus on the first term here and the first term in the divisor. So what is negative 4x divided by x? That should be negative 4. Write that up here on the quotient. Negative 4 times x, negative 4x. Negative 4 times negative 3, positive 12. But remember, we're subtracting. So instead, this becomes negative 4x minus a negative becomes 0. 4 minus 12 is negative 8. That's our remainder. This number right here, our remainder, is our answer. Notice it matches the same way up there. All right, now you're saying, that really was not faster than just plugging it in. I know, I get it. Let's do it with synthetic division. Let's see if it's a little bit faster. Okay, so we know our R is 3, because that was the number we're substituting in. Then we write down the coefficients, -3, 5, and 4. Draw our line, bring down the -3. Bring down our first coefficient, then we multiply r times that. So 3 times -3 is -9. Add 5 minus 9, or plus -9, is -4. 3 times -4 is -12. 4 minus 12 is -8. Look at that. There it is again. Okay, that was a little bit faster. That was at least the speed of this one. Okay, so synthetic division works. Now, if you look, flipping over the note sheet, if you're following along, what we did is actually called synthetic substitution. That method 2 with the synthetic division. Synthetic substitution is using synthetic division to evaluate the solution. So that's what we just did with method 2. This is useful when the degree of the polynomial is greater than 2. It could be less cumbersome. If you've got something in the 3rd, 4th, 5th, 6th power, and you've got positives and negatives in there, this could be a faster way to do it. That doesn't mean you have to do it every time, but for today I'd like you to try it. So let's do an example. Here's our polynomial, 3x to the 4th minus 2x cubed plus 5x plus 2 when x is 4. 4 goes in the box, and you have 3, -2, 5, and 2. You guys all like synthetic division, so at least we're using that, not the long division. Down to 3. 4 times 3 is 12. -2 plus 12 is 10. 4 times 10 is 40. 5 plus 40 is 45. 4 times 45. Uh-oh. Shoot. Okay. Okay, did anybody see the error that I made there and why I went, uh-oh? Look at this. We had a 4th, a 3rd. There's no squared term. Look at what we forgot to put in there. So we better erase. Good news is, some of this is okay. So that's why I'm not erasing everything. This is 4th power, 3rd power, 2nd power, 1st power, and no power. Okay, let's try that. 4 times 10 is 40. Sorry about that. 0 plus 40 is 40. 4 times 40 is 160. 5 plus 160 is 165. 4 times 165, 660. So our answer is 662. Now, you could go in and plug that in for good measure into your calculator and check and see, does that work? 3 times 4 to the 4th minus 2 times 4 to the 3rd plus 5 times 4 plus 2. And by the time you get that all punched in your calculator, you'll find out that the answer does, in fact, equal 662. It works. All right, the next 2 examples. We're not going to go back and do the second step. We are just going to solve with synthetic division and then move on. Okay, let's check. Do we have all the powers in descending order? Yes, we do. So 3 goes in the box because that is the value that we're using for r. It's the value we want to know about. 3, -6, 1, -11. Bring down the 3. 3 times 3 is 9. -6 plus 9 is 3. 3 times 3 is 9. 1 plus 9 is 10. 3 times 10 is 30. -11 plus 30 is 19. You plug 3 into this equation, you would get the same thing. Now, if at any point you want to pause the video and solve a problem on your own, then go back and see how you did, go for it. All right, let's try it here with number 3. So, -1 goes in our box. Uh-oh, notice we are missing 2 terms. So we got to put a 0 in there twice. We go 4, 0, 2, 1, 0, and -1. Now, I would encourage you to space things out because this time will be okay, but sometimes, like we had in the first example, the numbers get a little large, and so things get crammed together. Bring down the 4. -1 times 4 is -4. 0 plus -4 is -4. -1 times -4 is 4. 2 times 4 is 8. Or 2 plus 4, sorry. 2 plus 4 is 6. Negative 1 times 6 is negative 6. 1 minus 6 is negative 5. Negative 1 times negative 5 is 5. 0 plus 5 is 5. Negative 1 times 5 is negative 5. And negative 1 plus negative 5 is negative 6. There's your answer. Okay, so here we have remainders. Now we have to ask the question, what happens if we have a problem where we don't have a remainder? And that's what we're going to move into, and that's where this really becomes useful and important. All right, so we're going to talk about some sad polynomials now. Okay, not really, it's just a bad math joke. We are going to talk about depressed polynomials, though. Okay, go ahead and laugh, ha ha, yeah, thank you. Okay, so a depressed polynomial, or depressed polynomials, I'll make this have decent grammar, a depressed polynomial has a degree that is 1 less than the original polynomial. Well, guess what? When we have been doing synthetic division, we've been working a lot with depressed polynomials. We just didn't know to call them that, did we? If the remainder is 0 when dividing, that means the divisor is a factor of the polynomial. This is called the factor theorem. This is what we are going to be making use of as we solve polynomials. This is a special case of the remainder theorem. We're going to make use of this factor theorem because remember, our goal is to factor polynomials and solve to find out where they cross the x-axis. So we have to find their factors. So we have to show how, in this case, in number 4, x minus 5 is a factor. That's the factor. It'll be a variable and a number. Okay? So we're going to take, and let's do synthetic division. So r is 5. Remember, it's the sign opposite. Okay, we've got a third, a second, a first, and a nothing. Okay, no zeros that need to be added. Let's synthetically divide. Now, our goal is to find out whether x minus 5 is a factor. So is the remainder 0? So when we show this, we're trying to find a remainder of 0. And then figure out the remaining factors. So we'll put this into a form that we can factor or use quadratic formula on. Okay, so we bring down the 1. 5 times 1 is 5. Negative 7. Plus 5 is negative 2. 5 times negative 2 is negative 10. 7 minus 10 is negative 3. 5 times negative 3 is negative 15. Oh, good. We like this. That means we can write x minus 5 as a factor. And then the depressed polynomial, what is left? X squared minus 2x minus 3. But we're not done. We have to factor this piece right here. And we can do that simply, and some of you are going to go, I know what it is. Great, go for it. Just do it. But what totals negative 3 for factors and adds up to negative 2? Well, I'm thinking that you could have a negative 3 and a positive 1. And then you put x over it, because you put ax over it. So you have x minus 5, x minus 3, and x plus 1. And that is our answer. We didn't set anything equal to 0, so we're not going to keep solving. But that would be the next step. As we factored it, then we solve. All right, so that would be your answer, though, because we showed that x minus 5 is a factor by having a remainder of 0. And we found the 2 remaining factors. Remember, this is a third power polynomial, a third degree polynomial, so that means it won't have more than 3 factors. Let's take a look at another one. So to get used to this idea of synthetic division, today you're going to be asked to show that something is a factor and then find the remaining factors. So we're going to synthetically divide. So we'll have 2, and we have all the terms that we need. So we'll go 1, negative 7, 4, and 12. Do synthetic division, bring down the 1. 2 times 1 is 2. Negative 7 plus 2 is negative 5. 2 times negative 5 is negative 10. 4 minus 10 is -6. -6 times 2 is -12. Oh, good. That's what we want. We want a 0 here in the remainder. Now, let's write out what we have. Get x minus 2, and our depressed polynomial is x squared minus 5x minus 6. Can we factor that? You bet, and we need to. Remember, you got to do two parts here. So what multiplies to -6 and adds up to -5? Well, hopefully you're saying to yourself -6 and +1. Throw an x over them. Let's write it all out. X minus 2, x minus 6, x plus 1. So really what we're doing is we're taking our new concept of the synthetic substitution and the factor theorem and mixing that with some of the stuff from the last section of factoring and really previous sections. All right, last one. Show that x minus 3 is a factor, so we better get a remainder of 0 when we divide and then find the remaining factors. If it wouldn't be, by the way, if you wouldn't have a remainder of 0, then you would say it's not a factor and you're done. Okay, so 1, 4, -15, -18. Down the 1. 3 times 1 is 3. 4 plus 3 is 7. 3 times 7 is 21. -15 plus 21 is 6. 3 times 6 is 18. Oh, goody. -18 plus 18, 0. Whew. All right. X minus 3 times our depressed polynomial. X squared plus 7x plus 6. Can we factor that? Oh, yeah. We can. What two numbers multiply to 6 and add up to 7? Thinking, thinking, thinking. Hopefully, ding, 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 you have said 1 and 6. Put an x over them, put an x over them. So our final answer, x minus 3, x plus 1 times x plus 6. That is it. That, my dear students, is how you factor a polynomial. Tomorrow, we'll solve.